In this video, I'm going to teach you the basics of flying drones, what components you need to build a drone, and the basic principle on how a drone works. Welcome to my YouTube channel, Hot Gazpacho. I'm Martin, and let's get started. A flying drone, or a UAV, unmanned aerial vehicle, or UAS, an unmanned aerial system, which is basically the drone and everything around it which is needed for it to fly and to be controlled. For instance, a UAS can be the remote controller and the drone. Or if it's an autonomous drone, simply the drone is the UAS. I want to go through some basic terminology when it comes to drones and drone systems. One is the rotor. A rotor is any mechanical part that rotates in a system. When it comes to aerodynamic vehicles, a rotor is typically the rotating blades or the propellers. Thrust is the force generated by an engine or a propeller, and the thrust typically moves an object forward, and the direction of the thrust is in the direction of the engine or the propeller. Lift is the upward force that counteracts the weight and the gravity of an object. Torque is the rotating force that causes an object to spin around its axis. Hovering is when the drone stays at the same altitude in the air, and this is achieved by the thrust being equal to the force pulling the drone downwards to the ground, and this force is of course gravity. But also it could be air movement if the air moves up and down. Pitch is when the drone tilts forward if the front of the drone is in this direction, or backwards. Roll is when the drone is tilted to the right or to the left. Yaw is when the drone rotates around its axis, to the right or to the left. An aircraft which generates lift primarily through rotor blades or propellers are referred to as rotorcrafts. There are many different configurations of rotorcrafts with different number of propellers. And we of course have a single rotorcraft, a helicopter, which uses one large rotor blade to generate the lift that is needed to elevate the aircraft. And when this rotor blade starts spinning, according to Newton's third law of motion, any action will generate an equal and opposite reaction. What happens is that the body or the fuselage starts to spin in the other direction. And to counteract this, you need an anti-torque system. And this anti-torque system is, of course, the tail rotor, which you see in most helicopters. In a multi-rotor craft, you have the possibility to have the rotor spin in different directions. In this way, they can cancel out the torque, and you have no need for an additional anti-torque system. For instance, a quadcopter with 4 rotors, you typically have 2 rotors diagonally positioned, spinning in one direction, and the other 2 spinning in the other direction. By simply changing the thrust in the 4 rotors, you can control the drone, moving it backwards, forwards, upwards, downwards, tilt it, and roll it. And to understand why multi-rotor crafts has become so popular lately is due to the advancement in miniaturized electronics, battery technology, and software development. A single rotorcraft is mechanically much more complicated than a multi-rotor craft, since each rotor blade has to be controlled individually. In a multi-rotor craft, especially if there are at least 4 rotors, the engine and the rotors are typically fixed to the frame, and the craft is controlled by taking inputs from sensor within the craft, together with very powerful electronics and software, and controlling very carefully each individual engine and propeller. A flying drone can consist of a variety of components, with some are more essential than others, and the component configuration depends on the application and the purpose of the drone. The essential components of any flying drone are the following: a frame, a power source, typically a battery, a power module, which regulates the power from the battery to the components in the drone, a power distribution board, an electronic speed controller, which translates the power from the battery to a signal that can drive the motors. Motors and propellers. And with these components, you basically have a flying drone. However, this drone is not controlled in any way, and it would fly in a very unstable manner. You can power it up, set the thrust to half speed, and the drone would take off and it would crash. What the drone needs is a flight controller. A flight controller is a small computer which takes input from the IMU, Inertial Measurement Unit, which is a component which measures acceleration and angular velocity, telling the flight controller if the drone is moving, accelerating, whether it's tilted in any direction. The flight controller also takes input from other sensors and also takes commands from the entity that controls the drone. It could be an operator. So when the operator tells the drone go forward, it uses both that command with the speed that is expected and also from the sensor, that making sure that the drone moves forward in a stable manner. And the final component in the drone is a command and control system, or C2. This system controls what the drone should do. This system can be simply a remote controller with transmitters and receivers at both ends, or it can be something more advanced for autonomous drones, where specific commands and tasks are given to the drone. Additional components that can often be seen in drones are sensors such as barometers to measure the pressure, which in turn gives information about the altitude of the drone. GPS, which gives, of course, position to the drone. A compass, which shows the direction of the drone. A LiDAR, which measures the distance to objects around the drone. Optical flow sensor to monitor the ground movements in relationship to the drone. A telemetry module to monitor and send drone data to the command and control system. Camera, video transmission module that sends the video from the camera. An onboard computer, an RF transmitter and receiver, a 4G, 5G or Wi-Fi module. Hopefully now you will have a good understanding how a drone works and a good basic knowledge to be able to start building your own drones. Thank you for watching. My name is Martin, and see you in the next video.